All right, well, we'll get on to today's topic, which is classes. And as kind of a prelude, let's talk about the Java built-in string data type. You talked yesterday in recitation about array data types, which are kind of one step towards from the kind of simple numerical types we had to object types. Strings take us a little farther. Java has a built-in string data type, and the type name is string with a capital S. And you can initialize it like any other variable. The syntax for initializing a string to a literal is string A equals, and double quotes delimit strings. Remember, single quotes delimit characters. So that's cool. And what else can you do with strings? Java is pretty neat about overloading, let's see, the plus operator. All right, to mean string concatenation. So normally, plus applied to numbers means addition. Plus applied to strings means concatenation. So at the end of this, B would have the string A, B, C, B, C. Okay? So that's kind of neat. And just as an aside, it's also pretty good about automatically converting floating point numbers and basic types into strings. So you could actually do, if you're printing something, kind of say you had an integer, okay, and you called print line on this whole thing. It would actually be smart enough to say, okay, I'm trying to add a string and a integer, and what I need to do that is convert this to a string and then concatenate it with that. So this would actually print out the answer is 3. So just something that turns out to be very handy when you're trying to do output. String variables start to behave a little different from our integer variables in that they are reference types. When we had our integer variables, int A, int B. All right. What goes on here is the virtual machine or compiler allocates space for A and puts the number there, allocates the space for B and puts the number there. And if you say A equals B, it basically copies the value that's in location, the variable space for B into A, and so does an assignment. Strings work similarly to this, except if we have string A and B up there, so we'll just stick with those. String A and string B, what these actually are holding is a reference. This string, the actual set of characters ABC, isn't being stored in this variable A. What's being stored in this variable A is a reference to it. So this concept should be familiar to you from the scheme days, where these things, the actual data structures, are allocated off the heap, and that what you're storing is references to them. And the important implication of this is if you do A equals B, okay, in this case, now A and B are pointing to exactly the same object, exactly the same memory location. And if you were to change some part of that string, referring to it as A, which you can't because you can't change strings in Java, but if you did, B would reflect that change. One of the reasons you can't change strings in Java is that exactly that reason. If you do this kind of aliasing and then change one thing and something else called something else changes underneath you, it gets very difficult to follow. Another thing to think about with strings is that, as I say, and this should be again familiar with from your scheme days, if we have, let's see, DE. These pieces are allocated off the heap, and if I start out with A equals that, B equals that, and then do this, now there's nobody, what happens to this guy? You've allocated two pieces of storage off of the heap, and now you've kind of dropped one of them. There's no way for anybody to get that. And in Java, like in Scheme, that's taken care of for you by the garbage collector. Eventually, the garbage collector will run and will go scavenge that piece of storage and return it to you. One of the things you don't have any control over is when that will happen, which has an effect or some implications if you're creating a bunch of stuff and you need to know when it's going to be garbage collected. You have to kind of plan ahead for that. Usually, almost never that's an issue, but you always should be aware of what's going on behind the scenes. So,
yeah. Could you explain, because I don't understand why there's this difference between the numbers points to a location. The number points to a location in memory where it's stored, and the strings
right.
reference point to a heap.
Right.
So why would you do it two different ways? I don't really understand what the heap is.
Well, let's see. Normally, when you do a method call, all of your local variables for the method are allocated off of the stack, and the stack kind of grows downwards. And you would have local spaces, for local variables A and B. And these are generally of small size, like 4 bytes or whatever, depending on what type you declare them to. Now you could, and C++ lets you allocate objects off of the stack. Okay, so if you had, it would allow you to allocate a big chunk of data off of the stack. Okay, Java just does not do it that way. If you allocate a string, it kind of over here allocates a chunk of memory that it's going to manage and gives you a pointer to it. And does that. It, in some sense, does it because they decided to put garbage collection in at a deep level. So they figured they could manage all these and save you the trouble of having to manage all these. One of the things that's nice about it is if you did allocate some object off of the stack, okay, so you had this big chunk of data, and you wanted to return it to some variable, to somebody, you'd have to either copy it or it would go away. Once a method returns, its whole stack frame goes away. And so while the stuff on the heap stays around, the stuff on the stack vanishes. So just a language design decision, but something to be aware of. Now, strings are a special built-in type because they're not only a built-in type like integer, such that you can use this initialization syntax and you can use inline operators like plus. It's also an object type, and it's the first object type we'll see. The way you notice it's an object type is that there are operations you can call on it using this dotted syntax, which people brought up yesterday. For example, one thing that you often want to know when you're dealing with a string is how long the string is. Right? And for arrays, we had a there's a magic property on arrays called length. So you would say, if a was an array variable, a.length, and it would return to you the length. Strings, being an object, have a method called length, which is a routine or function associated with the string that you can call, and the syntax for method calls, for instance method calls, is a.length. And this, if a is a string variable, is going to return the length of the string in the number of characters. So here we started out with a equals that. We assigned it to b, so this would actually return 2. Let's contrast that with the with when we were writing factorial yesterday. Okay, inside our main program, we defined a public routine fact, and then inside our main program, we just called factorial of 3. And the difference here with methods, or this particular type of method, instance methods, is that they are associated with a particular object, all right? And their behavior is not only a function of, or depends on the function name, but the object you call them on. For example, if I had, let's say, I did b equals f g h, and then b.length, okay, the same routine, same arguments out here, but different object you're calling it on is going to give you different results. It's going to give you the length of b rather than the length of c. Okay? So what's really going on here under the covers is that although length here looks like it has no arguments, it really, and this is true of all instance methods, they really have a secret argument or an implicit argument, which is the object that you call it on. So what's really going on is when it calls, the system is calling this length function, it's giving it the object pointer that you called it on as an argument, which is how, without any arguments, this length can behave differently than this length. It's actually doing quite a bit more magic, which we'll get to later. So this is how somebody gives you a class, this is how you call methods on it. And the way they tell you what methods you can call on it is through the documentation. If you go to the Java website that I gave you a pointer to in that handout and click on the java.lang package, and then it'll give you a list of classes. If you click on the string class, you'll see about 20 different methods that you can call on strings. Length is probably the most useful, but there are lots of others that will return you substrings, that will return you a character at a given position. There are a lot of different methods that the string class supports on instances. There's another class of methods that are called static methods. And we saw some of these yesterday with our defining main, we defined static, and our factorial routine we defined as static. Static methods are methods that are defined inside of a class, but don't really have any particular instance associated with them. They're doing kind of more global things. The string class only has one set of static methods, and they are called, let me think, I believe they're called value of. And the syntax for that is and basically this is the definition of it, and the way you would call it is And this would return to you basically the string 3. Okay?
So capitalized or
Yes, exactly. Value of, and this is kind of standard Java convention. This is the name of the class that it's a static method of, okay? So instead of giving it the name of a variable you want to apply it on, because when you're trying to get the string value of 3, you don't have a string yet that you can apply it on. So you just want to say, you know, give me the value of method of the string class. So you call the class name, dot is more or less the scoping operator, and then value of. And the Java convention for methods is typically that they begin with a small letter. And then if you have a multi-word kind of phrase that describes what they do, each new word has a capital letter. That's not enforced. That's just a convention. But you'll find lots of things that are written that way. So here, since we're calling on variables, these are instance methods. They don't use that syntax. And you just call them on the variables. These methods, the static methods, also do not get the hidden argument that these guys do. Yes?
Could you clarify what you mean by instance?
Instance. Okay. There's what we call, this will become clear clearer in a few minutes, but there's the kind of notion of string, okay? And then there's particular strings, all right, that you've allocated. So particular strings are instances, okay? They're when you actually go and allocate a particular string or class or something, they're just called instances.
What is a class?
What is a class? Well, good question. And that's the next part of our discussion. So basically, classes are a way to let you, the programmer, extend the type system of Java. Java gives you these built-in types like int and whatever. They also give you a built-in type called string, which both has some properties that are like the integer variables and that you can use plus on them, and some internal operators in it they're recognized specially, but also that it has these built-in functions that you can call on them. All right. Now, once you do everything you can do with strings and integers, you'd like to be able to do more. This ability to define functions that apply to things is pretty powerful. So Java lets you define classes of functions, which essentially new types. All right, and the types behave a lot like the string type in terms of syntax. And perhaps the best way we can go through or kind of start to address this is through an example. And what I want to go through is a type that represents two-dimensional vectors. Okay, two-dimensional vectors represent points in the plane, and they have an x-coordinate and a y-coordinate, and you can do a bunch of operations for them. So if you're doing, say, a 2D graphics program, or you're doing some kind of 2D physics program where you're computing physics in the plane, where you have to deal with velocity vectors and acceleration vectors, a 2D vector is a nice data type to be able to work with. In some ways, the heart of object-oriented programming versus other techniques is to think of the basic option things you're trying to deal with, for example, a vector, and making a type out of them, as opposed to saying, okay, I need 5 vectors. Each vector has 2 integers or 2 floats associated with it, so I'm just going to allocate 10 floats and remember which one of these floats kind of is which part of which vector. You can certainly program that way, but if you have 1,000 of those things, you're going to go insane pretty quickly. And thinking of them in terms of a vector type that you can then say, okay, give me the length of this vector type, as opposed to having to say, where's that x coordinate, where's that y coordinate, do some computation, is much nicer. So Java basically lets you support this sort of thing. And the way you do it is you need to define a new class. And I'm going to call the class vect2d because there is already a class called vector in Java which does something completely different than what we want to do. And I'm also going to add a keyword public because Java has a bunch of notions of security, and public basically means that everybody can look at this class. There are other, you can also say this is private, which means that no one can look at this class, which is useful in some circumstances, but probably not at the class level. JavaDoc needs this public keyword out here to function, so it's good to put it in. If you leave it out, it'll be put in by default. Put in your curly braces, and a class definition. We're writing a new class. You need to add basically two sets of things. You get to add some data variables that describe the contents of these objects, or what you need to carry around to implement this object, and then you want to write a bunch of methods, which are, again, the Java name for procedures. And these procedures are going to manipulate those pieces of data. So for our two-dimensional vectors, okay, what totally describes a two-dimensional vector? X and Y. And we'll use doubles to represent them. And you need to basically have a section in your class definition which declares your variables. And these are called instance variables. And you, again, need to, let me add these, declare who can, as good practice, who can access them. So we're going to make these private. I get tired of writing private all the time, but I guess I will just have to live with it. What private means is that the only code in your entire system that can ever see these variables are the codes in methods that you write on your class 2D. Any other, over in your main routine, there's no way to ever get at these variables. So this is nice because it hides your implementation from anybody using it. People who are using, for example, when you use the string length method, you have no idea how that's being computed. You don't know whether the string internally keeps a number that it remembers as the length, or that every time you call it, it kind of marches down the string and figures out how long it is. You don't know, you don't care. All you know is, and all you have to know is that when you call length, you get back the number. So we're trying to specify behavior abstracted from implementation. This is one of the keys of object-oriented programming. Okay, you want to think in terms of what a vector is at a high level and what it does, how it behaves as a black box that you say this to it and it gives you back this. Okay, without worrying about how it's implemented, what's inside, how efficient it is, or whether it's implemented the same way today as it was yesterday. So when you declare instance variables, you should almost always make them private.
If you made them public, would it really
Well, the consequences, if you made them public and then never ever used them, it wouldn't screw you up at all. But if you used them, okay, if you took advantage of the fact that they were public and used them in some other class or some other module or in your main, and then decided that this representation was crappy, and what you really wanted to do is represent a vector in terms of its length and its angle, all right? And then somebody went in and changed those, then your program breaks in about 1,000 places. Whereas if you make them private and never use them anyplace, you could change your representation, rewrite all of your methods to use the new representation, and nobody else ever knows.
This is for like team programming.
This is for like team programming, which is pretty much all programming these days, or at least what object-oriented programming is in part all about, is getting large, fairly straightforward but very large programs to actually come together and happen and be maintainable. Because in the real world, you not only have team programs, but you often have revolving team programs. So, people leave the team, new people come onto the team, and so the program has to be self-maintaining, self-documenting, and well-structured. So
what would happen if two different classes have those, like for example, X as being public?
Right.
Use that in the third class.
These variables are scoped to this class. So if I had a vector 3D class, okay, that had an X, Y, and Z in it, they would not conflict with this X, Y, and Z even if they were public. Because you would have to, in order to specify something like we did over here, you have to give it the name of either a variable to get at it of that class, or as we did in an instance variable, here you would have to say vec2d.x. Oops. Okay, if we had two classes, vec2d and vec3d, all right, you would have to refer to get at the x in either one, you would have to use this prefix with the dot to tell how to get at it. So there isn't any naming conflict. The problem merely comes in terms of visibility. Who can see it, who can modify it, and who basically will write their program depending on the fact that these x and y's are there. And the answer you want is nobody. So you don't want anybody to know how you implemented your classes and base their implementation of something else on your implementation of your class. You only want them to base it on the behavior, the contract that kind of you publish as what your class will do.
So it's just to kind of save yourself from having too much information.
It's to save yourself from, exactly, or to save somebody else from having too much information. Because you would always do the right thing, but you just can't trust other people. That's the problem.
So I guess I'm still not really sure what's the difference would be to make public or private.
Well, all right, right now this is actually a sufficient class. And let's say we made this one public. Let's do things. Oh. Erase that from the tape. Erase that from the tape. We'll edit later. Yeah. So now let's talk about, a little out of order, how we want to get one of these things. Say we've defined this class. This is actually a perfectly happy class. And if we put it in a file called vec2d.java and ran the Java compiler on it, it would give us a class file which we could then do stuff with. We couldn't do very much stuff with it, but we could make a new one. And the way we would get a new one of these is to say, over here in our main program, say we said vec2d equals v, and we use our new operator. Did Alan get to the new operator when he talked about vectors?
Yeah.
Or arrays, rather? Yeah. Okay, so this is the same new operator, which is the way you tell Java to get you something off of the heap. And in this case, what you're telling it to get off the heap is a new 2D vector. This is actually a more complex syntax than arrays, and this is actually calls a special method called a constructor. And if you give it you are allowed to pass in arguments to let you initialize, In this case, we initialized our strings using this syntax. For a vector, Java doesn't give us any syntax to initialize a vector. So we, in order to get one, we have to be able to pass in things. Now here I'm using passing in nothing, and Java always automatically generates you a null constructor unless you override it or tell it not to. And what this is going to do is basically make one of these and probably make up something to put these on, to put in these values. So for good practice, we should always initialize our instance variables. So now, when this happens, Java will say, OK, I've got to make a new vector 2D, and I'm going to use the default initialization, which is going to, so it allocates me a thing off of my heap, which has 2 slots, an x and a y, and it has it fills that in with 0.0, and it's essentially returning me a pointer to this thing. You don't actually have to worry about that, but that's more or less what it's doing.
But Java is guaranteeing that it's initialized like that.
If you don't put these initializations here, then you don't know what's going to happen, which is why you should always, when you declare your instance variables, put these in. But yes, if you do, it'll fill in these values. I wouldn't depend on it. It's probably part of the language semantics, but never good to depend on. And certainly, if you get used to doing it one way and switch to another language like C++, has similar rules, but the initialization, the default initialization will vary based on what compiler you're using, whether you compiled it debug or not debug. So always initialize these things. Well, now that we have a new one of these things, what can we do with it? Well, since we don't have any instance methods, we can't do very much. But we do have one public variable that we can do something with, and we can access that, if we want it to be nasty, through this dot syntax. So v, our vector, dot y, which is our variable, tells us to get the y instance variable in this new vector v that we just created. All right, so, and here, say we set this to 3.0, and then said, let's see, I should have used ints since they are easier to type or write. All right. What this is going to do is go look in this place, which we just assigned 3 to, find 3, and return that an A. Now, I told you that we don't want to make things public, because if I changed, say I was just silly and wanted to change that variable from y to z without telling anyone, now this program would break. Not very good. So always keep these private. But now if they're private, how do I get at them? Over here, the compiler is now going to generate all sorts of errors when you try and compile this. It's going to say, there's no public variable y in class vector. What are you doing? And so you have to do something else. And the thing you have to do is to write methods to allow you to manipulate things. And one class of methods that is very important, and you always have, or often have, are called accessors. And what accessors are is basically mechanism to get around the fact that you aren't going to let anybody read your variables. So typical accessor for something like this, double All right. Let's get rid of this little annotation and put in a comment. So here we have just defined a function call or a method. I'll just use that term all the time. And let me go and this one we're going to declare public. So public says that anybody can call this method. Double says that this method is going to return us a double. GetX is the name of the method. And Java, another Java convention is that accessor methods should have this naming syntax. So if you have a variable called small x in your program, then you have a method called getX, which returns the value of x. If we had a value called small name over here, our accessor would be get name with a capital N, but not the rest of the things capitalized. That's just a convention, and again is not enforced, but there are a bunch of things that kind of hope it's going to be true. So, okay, so here's our class method, and now we can make one of these for y also. Say we imagine we had, and now this part of the thing we can now say now we're calling our method. I'm going to cheat and just turn that into the y1. All right. Sorry.
Do you need a semicolon after the closing bracket or not?
No.
No?
No. For this method declaration, you just need an open at the beginning, turn at the end. So this basically takes this hidden thing and gives it out again. All right. If we were going to let people change the values, we would add a different set of routines for each of our variables that are typically called mutators. All right, and they typically have a syntax public. They typically return void. I believe they're usually called set. And in here, okay, what we want the semantics of this to be, if we were going to support it, is we want to be able to set the y variable here to this. All right. Now, when you're first writing these things, your inclination would be to write y equals y. But then that doesn't quite look right, because what this is really going to do is take this variable y and assign it to itself. I've done this too many times, and it lets you do this, but it means something. What you really want to do is take this y and assign it to that value. And this gets into the idea of variable scoping, where kind of your variables are always scoped to the nearest enclosing scope that defines them. So as this defines a variable called y, all instances of y, or examples of occurrences, that's a good word, occurrences of the variable y in that function refer to this argument. So one way around that is to just call this y1, and I say y1. So now everything works the way I expect. The value I pass into y1 gets assigned to y, which is that y in my instance. All right. Another way to do that, to get around this, is you can refer to this y explicitly, because remember I talked about here that there was a magic variable which was being passed into every one of these methods on instances. And that magic variable is called this. So you can say this dot y, and this is magically bound inside any method to the thing you're supposed to be working on. So this dot y always refers to the y value in the particular instance that you're working on. Very handy. So I could even do double y, this dot y equals y, and everything works fine because this dot y resolves to this. That y resolves to the argument you pass in. Everybody's happy. Is everybody happy here? Any questions?
I lost the private thing notion again.
Okay.
If you have methods that set y, why can't you just have y be public?
Well, because, again, it comes back to a matter of this is essentially enforcing a view of to the outside world of what it can do to your vector, whereas these are kind of the representation of how you're going to represent it. Now say, again, I decided to go back to a representation internally that actually was a r and theta representation. Okay, so instead of x and y, I was storing r and theta. I can still support a set y operation. Okay, or certainly it's easy to support a get y operation. Get y is just r sine theta. So I can compute that in here, return that. Nobody knows the difference. All right, to do a set y, I have to do something a little more complicated. I have to kind of recompute my r and theta based on the same x value and the new y value. But nonetheless, the person calling just sees set x and set y. He doesn't know that I've stored it in terms of r and theta, which is the whole beauty of it. So I can switch back and forth between those representations without anybody who's using the class having to ever know the difference. So, yes.
With writing the numbers, you go 0.0 on the floats. Is that a style, or do you?
That distinguishes it from an integer. I could probably write just 0, and it would automatically convert it to. So yeah, it's just style. Yeah, yeah. So. All right, well, we have a class here, and we have some methods. We have a methods to get our components, method to set our components. And in this case, what I want to do is delete, say we don't have a method to set our components. Say we have no methods that allow you to change the components. This is a particular implementation choice which gives us what is called an immutable class. That once you make one, you carry it around, you pass it around, you operate on it, but you never change it. Okay? Some classes are immutable, some classes aren't. The string class, for example, is immutable. Once you've made a class or made a string, you can't change that string. You can concatenate it and make other strings. You can get a substring of it, which is given to you as a new string, but you can never change the guts of it. Making classes immutable has the nice property that that if you make a class or make an instance of one of these vectors, okay, that say, -1, -1, and you have one of these and some variable, you know that nobody else is going to be able to go in behind your back and do a set y and turn that to like -1, 0, some other part of the program. Or so you can pass this thing around with impunity and know that no one's going to screw you up. The disadvantage is that every time you want to do a new operation, say you wanted to normalize this vector to point in the same direction but be of length 1. Okay, that's an operation which you could conceive of doing two ways. You could either have a normalize operation which you call normalize on a vector, and it gives you a new vector back, which is the normalized version of that vector. Or you can conceive of having a normalize operation which just changes that vector to one that's of unit length. Two different implementation choices. Both of them work. One of them is safer, but on the other hand, the one where it's immutable is safer, but then you're always making new things every operation. The one that is mutating things and scaling them internally, you're not making a new thing, so you're kind of saving memory and work, but it's a little more risky when you pass it around. So it's a design decision. Could go either way. Cool. So this is really it. The rest of object-oriented programming is just writing methods. Yeah.
So how do you, when you're creating a new vec2d, how do you initialize your x and y to be what you want?
Good question. Our next topic is how do you initialize x and y to be what you want? And you do this by writing constructors. And constructors are just methods that have a particular syntax. They are always called the name of the class. Okay? And they don't return anything. So you don't specify them as returning anything. They do have a access type. So you can write secret constructors, private constructors. And you can write constructors with arguments. So double x, double y. And internally, this dot x equals x. Some people would probably object to my passing in arguments of the same value of that and using this syntax. For me, I have very limited imagination in terms of what to call variables, so I tend to do this a lot. Some people might not like it. It's just a matter of style. But constructors, it has no return type, can have arbitrary arguments, and basically it initializes, can perform arbitrary computation, but it basically has side effects to initialize the instance variables.
We don't have to specify void to
No.
specify that it has no return?
No. It's the strange thing about constructors, but constructors can't specify a return value. If you specify void, it will complain.
Okay.
Yes. Don't.
But how does it know that it's a constructor?
It knows it's a constructor because it has exactly the same name as the class.
Oh, okay.
It's smart enough to know that, so if you do this and you call new vec2d with arguments, it uses the constructor, and without arguments, it uses the initialization.
Right. What it actually is smart enough to do is, it's even smarter than that. It allows you to overload your constructor. Actually, you can overload all methods. Let's say we found ourselves allocating a lot of vectors along the x-axis. We might want to have a special constructor that just does that. It takes one argument and says just it overrides the x coordinate. So here I could go double B equals, yikes, equals, so let's do this for real, 3.0 comma minus 1.0, all right? What? Ah, you're absolutely right. Absolutely right, yes. Get rid of my little diagram here. All right, so we have two vector variables which we've initialized, A and B. We have two calls to the constructor, one of which to our constructor with two variables. So it says, okay, I've got two doubles as my arguments, so I'm looking for a constructor that has two doubles as its arguments, and it matches them up. It finds that, and it executes this one. Here it says I have one double as an argument. I'm looking for a method that has a constructor that has one double, and it uses that one. All right. Now, when we think about this one, we can ask the question, what happens to y? All right. And when you have constructors, the initialization sequence works as follows. First, it goes and makes the thing. Then it does the initializations assigned to the actual variables in this sequence. All right. Then it goes and runs the constructor routine, and it overrides the variables whatever there. There's actually a middle step, which I've never used and never seen anybody use, but you can actually put, using curly bracket syntax, some initialization code in here, which also changes these guys. Okay, so what would happen is first, it would do this assignment, then it would execute this code, which, if it had any assignments to x, would do that. Then it calls the constructor. You almost never need to use that, and it will probably confuse people if you do. I will mention it for cultural reasons, but that's about it. When I do this, even single thing constructors, I like to be a little redundant and make it explicit that what I'm doing is making something that's allocating a vector on the x-axis. So I'm not making the reader of the program kind of remember what order things happen, and that this guy carries down from here, but this guy's overridden. So, yes.
If you pass integer as argument, will it convert it to double?
I guess the answer is yes. I mean, that gets into the question of, given you have something of one type and you try and use it as a different type, how far is Java going to go for you to try and convert it from one type to another? And sometimes it will just do it and not tell you. Sometimes the compiler will complain to you and say, if you really want me to do this, go and tell me to do this explicitly. And there's some syntax to kind of tell you, to be able to explicitly say, I really want to convert this into a double, or this type to this type, and do it explicitly. So you can, in general, when you're trying to do that, doing shortcuts, try it, see if it complains. If it complains, you have to go and reassure it, basically. So
So can you always construct an object with 0 arguments as the first example?
I would be inclined to say yes. It gives you a default constructor I have run into systems that will give you the default constructor until you add a new constructor, in which case, even if it has arguments, in which case it kind of stops giving you the null constructor and you have to go put it in by hand. Just put in a something that doesn't do anything. So my inclination would have been to say yes, but I have run into situations where I've added constructors and it's complained and I had to do something like that. So that's
not in Java, that's in some other language?
no, that's in Java. That's in Java. So
Versions of Java that make sense?
possibly, I have no explanation for that, but just something to be aware of. It might be, me having a bad day or something, but just something to be aware of. One other thing to know about constructors is this is pretty much the only time you can use them is in the new expression. You can't call them like an ordinary method. You need to use new to call a constructor.
I just have a question about the
Yes.
arguments that you pass in.
Yes?
They can have arithmetic in them, they can be calls to other methods.
Arbitrary expressions. Right.
Can you write little programs there?
No, they can just be expressions. So in that sense, arguments, you have kind of pure functional code you can put in there. So just stuff that evaluates, but it has to be an expression as opposed to a method definition or a set of statements. All right, so
Oh, one other thing, can you skip the first argument with a comma?
no, I didn't. I've never seen that. I honestly haven't checked the syntax book to see if you can, but no, let me take that back. It doesn't make sense because the routine is expecting it, and what do you do with it, right? It doesn't have a value, and it needs a value. So it's unlike something like Lisp, which has default values for procedures. There are no default values for methods. There are default values for instance variables, which you put in here, but when you're defining a method, you don't get that for free. But actually, let's write some methods that deal with vectors themselves. So what can you do with vectors besides give me either make a new one and then give me the numbers that I just gave you back, right? So far, we can create a point and we just can get the things we gave you back. So one simple method that we can do is ask is the length of a vector. So public, that'll return a double.
Is it just public or private? There's no clear.
There is a third one called protected. And what protected means is that this class and its subclasses can use it, but nobody else can use it. I think stylistically, people prefer just private.
There's no like celebrity class. Most people
Right. So, and the length of a vector is 3. X squared, the square root of x squared plus y squared. All right. Now some of this syntax becomes less mysterious than it was yesterday when we were doing system.out.println. This implies that there's a class somewhere that Java gives you called math with a capital M. And all this class does is it doesn't have any instance variables that are interesting. All it has is a bunch of math routines, hanging around for you to use. In lots of languages, you would just have a math library as a set of procedures, which you could call, that are built in. Since in Java you don't have any procedures that aren't methods, every single procedure, even your lowly main, is part of a class. So you need a class to hang all these math routines on, and so it's called the math class. And since they're all static methods, they don't have any instances, you just use the class name and then the square root method, and it's defined to take a double in and give you a double out. So here we're computing the square of x, square of y, summing them, returning the square root. It, of course, returns you the positive square root, and that's what we're returning for the length. Pretty straightforward. And since this is an instance method, we would say, call it b.length. And that, as an expression, would return 1, since in our simple one, the length of that vector is 1. If we call a.length let's see, 9 plus 1 squared of 10. So this will return you a double expanding out the square root of 10. So that's cool. Any questions? I still have 15 minutes. Yes?
Just a question of strategy. I noticed that every time you call the length function, you're going to have to do a calculation using math. It's not a very bad calculation in this case, but I'm wondering if you wouldn't want to, if there are cases where you wouldn't want to put another variable in your class to hold on to the length, so that you would only do that calculation, say, the first time the length would call.
Sure.
Check and see if there's a value in that variable and simply return that.
Absolutely, absolutely. Especially since you have an immutable class, you're never going to change it. You could easily put the variable there, do it in the constructors, or if it was very expensive, only compute it the first time you were going to use it. If it's very expensive, you might not even want to do it every time you did the constructor, because, as you say, you'd have to do the work then, and you might never call the length. So yes, you could do lots of strategies like that. Put in the extra length variable, and that's one of the nice things about this kind of data hiding implementation or scheme, is that nobody has to know whether are you doing that optimization or not. And you can start without it. If your program runs too slow and you find you're calling that a lot, you can go put in that extra variable and modify the implementation of length, and everything still works. And that's just a nice feature.
You talked about the possibility of having code sort of in kind of the main level of the class there, right after your declaration of variables. Would a calculation like that, an initialization calculation, be something you would do there, or do you think you should just leave it in the constructors?
You could leave it in constructors. For that matter, you could just put it in line, although I haven't used this feature. I can actually put an arbitrary expression over here.
But wouldn't that always perform it on the 0 assigned to x and 0?
That's a very good point. Yes. Yes. So you're right. You would have to override it there. Very good point. All right. Never mind. Never mind. Never mind. But you can allow arbitrary expressions in these initializers, and it goes through them in this order. So in this initializer, you can use this, and in the ones below it, you can use the ones above. You can't do the reverse. You can't shoot forward and do these circular dependencies and the like. All right, let's do a method. So far, all we've had is methods that take kind of numbers and return numbers. Let's take methods that do something with vectors and give us vectors. For example, one thing you do with vectors is add them. And adding vectors is pretty easy. You take the x component and add them, take the y component and add them, and you return a new vector with the sum. So public Now, addition is kind of different from what we've talked about so far in that it's a binary operation on vectors. All right. So we have kind of our instance vector, and then we have this other vector. And so the first way I'm going to write this is as an instance method, and we're going to pass in all right. I've really got to come up with better variable names. All right, so our semantics are here that we have the vector that we're being called on plus some other vector that somebody's giving us. We want to add them together and come up with a new vector, which is the sum of those guys, and return it. So how do we do that? We need to get a hold of our x and y, which we can get a hold of easily. We need to get a hold of A, the x and y for A, and we need to make a new guy. So let's do it in the reverse order. Let's make a new guy. No, never mind. I'm going to do it in the first order. I'm going to say, first I'm going to compute my new x coordinate. I'm going to call it nx instead of new x, because new is such a reserved keyword that although I could say new x with spaces, just, I don't know, gives me the shivers. This is going to be our x plus this guy's x. And we refer to that guy's x through the normal a.x syntax.
You can do that even though it's private.
Exactly.
It's within the class.
This is private, and we're doing it here. It turns out that a method on the vector2d class not only has access to its own x and y, it can get at the x and y, the private variables of anybody of the same class, as long as there's an instance in scope. So this method can have access to these guys. Now, if there was some other 2D vector out there, maybe in my program, say this guy B over here, you couldn't get at this guy's x and y, not because it's private, but because you don't have any reference to that B. He's just out there in space. The only guys you know about are the guy that got passed in and yourself. So
You could also do it by a.getx if you wanted.
yes, that would equally work. You could also call any of the methods that you already defined on your vector2d class.
Would you sometimes do like this dot x to make it more clear?
Yes, you could also do this dot x, this dot y plus a dot y. And then, now we have our new components. We just need to make a new guy and return it. And Java lets you, although it's very disorienting at first, it's good to get used to it. Lets you use this new operator all over the place. You know, you're used to seeing it in this initialization syntax where you say variable a equals new vector. But it turns out there's lots of handy places that you'd like to use the new operator. And here, this is just saying, make a new vector, initialize it with these guys, don't call it anything, just give it back to me, and I'm going to return it immediately. So it's, I find it a little disoriented at first, but it's just an enormously handy syntax. So going back over here, we can now write, make a new vector called C, and we have our two vectors here. We can take A, and we can add B, And now we get a new vector whose components are going to be 4 and -1. And it's a brand new thing. And it doesn't share anything with either A or B because we've created a new object. So, any questions on add? Yes?
Use the plus option.
No, that would be really nice. And you can actually do that in C++. C++ actually lets you override the arithmetic operators and redefine them to operate on your object types. It's kind of cool, but when somebody does it and you read their programs, you typically wish they hadn't. But Java does not let you do that, probably for that reason. So yes, once you're outside of strings and ints, you're forced to do this sort of thing. Now, one thing that's kind of unsatisfying about this operation, here we have a binary operation on vectors, which is symmetrical. You know, A and B, we're adding A and B, but the syntax is not terribly symmetrical. We're kind of treating A as, you know, our main guy, and then we're saying, this is sort of saying add B to A, all right? Which is one way of looking at the world. You might want to have an instance that's fully symmetrical, that just says add A and B, kind of from a philosophical point of view. And you can write that sort of routine too. That would be one of our static routines. We could rewrite this. Let's see, I'm out of space here. Can I erase this guy? Oh, good point. All right. Imagine this routine is in our class over there, since you can't just place these things anywhere. They have to go inside the class curly braces. But we have an extra keyword we can add, public static add. And now, because it's static, we don't get the this variable passed in. So we need to have two variables, vec2da, vec2db. No, it does need a return type. I just forgot it. All right, that's vec2d, squished small. The static means that it is a routine associated with the whole class, okay, rather than any particular instances. These, without the static, are associated with instances, meaning they get this magic this variable passed in. Static methods don't get the magic this variable passed in, which means if we want to add two numbers, we have to pass in the two numbers that we want to add into the thing. So then we just write our routine again. But in this case, we don't have any this. We have to write a.x, b.x. And then our return. And that's our routine. Now to call it over here, instead of calling it on a particular vector, we call the class name I'm sorry, yes.
Because of overloading, we should have both of these methods, and
Well, this is less an issue of overloading. Overloading usually refers to different signatures. Here we have a static method, and it's scoped differently because here we're calling it on an instance. Here we're calling it on the class name, so it knows how to do that. We could actually give it a, we could do overload these also. Say, I found that when I was writing my program and I was adding 2 vectors a lot, I find that a lot of what I have, again, are these vectors that just have x components and have a y component of 0. And say that what I do with these things all the time is just add them to an existing vector. So say I decided when I wrote my programs that it would be very useful to have a method that would behave as follows. I'd like to be able to vec2d c equals, and I'd like to take a vector and add say just a double to it, and what I want the semantics of that to be were to be just like I made a new vector with my unary constructor, and then I did the add operation. So we can do this one as well. We can write public vec2d add of double x. And in this case, we would have double nx equals this dot x plus the x I passed in. We would have double ny equals this dot y. And I return new, sorry, I have to have a return in there. Return new vec2d and x and y. Okay, so now this add method does just what I described. It's going to take this double and come up with a new vector which adds the x component, keeps the y component the same. Now the cool thing is that this add method, which has exactly the same name and 1 argument, and this add method, which has the name add and exactly 1 argument, can happily coexist because the Java system has enough information to figure out for any given call which one to do. Okay? It knows that, basically it has the following pieces of information for any method call. It has the name of the method, it has the types and number of arguments, and it has a return value. So basically you're allowed to make 1 method for every unique combination of that information. Now say I wanted to have a method that did the same thing as this, except I pass in a y, and it adds this to the y. Now I'm stuck, because the signature of that would also be vector add double y, and it does not distinguish the names of the arguments, only the types of the arguments. So if I wanted to do 2 different add methods that passed in, I'd have to get creative with my naming and go name x or add y. So there are limits to what you can do with overloading, but it's nonetheless a useful thing.
Is it also called overloading when you have like the same method with different number of arguments?
Yes, yes. Overloading is typically when you have the same name and different signatures.
And for example, if you call this the double double there if you called it with an int, automatically classes for double?
In that case, yes. And that brings up a point. Say that, say you have a bunch of overloaded methods, and then, with some complex sort of type thing, so, and then gave it something which could be converted to one of the other types. How does it know which one it's going to convert to? And how do you know which one it's going to convert to? The short answer is, if you have to ask that question, you shouldn't be writing that code. You should make it explicit as to which one you really want it to call, if there's a choice. Sometimes the compiler will complain. Sometimes it will. For example, if we had a routine that added a double, we could have an equivalent one that added an int by first converting it to a double and doing this, and then say we call it with an int. It's probably going to be smart and pick the int one because that's a closer match. If we didn't have the int one, it would convert to a double. Say we called it with a short. Now it has the choice of converting the short to an int or the short to a double and calling either one. And say they did drastically different things. You can see it gets very confusing. So if you write or call a lot of overloaded methods, make it clear as possible, both or on the call side, which one you want. So, and I can do that by basically using this cast syntax. I don't know whether Alan talked about the cast syntax, but okay. Cast syntax is basically before any expression, you can put a type in parentheses, which is going to tell the system that I want to take this and convert it, if I can, to that type, or treat it as that type. So this way, even though I gave it an integer, it's clear I want to convert it to a double, and it's always going to go to my nice double routine. So use casts. We'll talk a lot more about casts tomorrow to make it clear what we're doing. So any other questions? That's, I think, pretty much all I have to say.
In this
Yeah?
class, the code is all in right there. Can you define the code elsewhere?
No. In some languages like C++, you're allowed to use a syntax to kind of, this is C++ syntax, you would be allowed to say, and define it there. It has this kind of double colon scope operator. But in Java, you can't do that. So everything has to be inside the class, which is a pain because if you have a lot of methods in your class, they all have to be inside the class has to be inside the file of that name. You can get these enormously big files, which the Java object-oriented programming people would say that you're making your class too big and you should break it up into lots of smaller classes and use them. But sometimes that's not a very satisfying answer. And sometimes there are just classes which have a lot of methods. Like I imagine that math class is huge. So since it has basically a whole collection of math routines in it.
So if you're really Java hacker, would you like to do the instant other class method for the adding?
Which? Oh, the static versus the instance?
Yeah.
If you're writing a class, you would probably provide both. Okay, so that you let the user have a choice of which one they want to use, whether they want to emphasize the symmetry or the kind of do this to this aspect of it. This syntax, the instance syntax, has a nice property which we will get to tomorrow when we talk about inheritance, that you can do very clever things with that syntax involving what's called polymorphic types, where you can basically have things of one type and call it another type, and then call the add method on that other type, and it'll go and do the right thing on the original type, and you can do some clever things that way. So that's the advantage of this syntax, is that it has all the instance information of this guy, that the guy you're calling on is treated very specially as an argument. So there's lots of clever things the system does there. The trouble with it is that it only does it on the first argument. It doesn't do anything clever with all the other arguments, and sometimes you'd really like all that clever stuff to happen all over the place, but it doesn't.
Are there performance differences between static and instant methods?
Probably. It depends in part on how complicated a class hierarchy you've made so far. We haven't talked about, we'll talk about inheritance tomorrow. If you just declare things like this, it's probably not significant. But in this case, it might be. But on the other hand, if that's your biggest performance problem, then first of all, you're in such big trouble already if that's a performance problem that you're probably doomed. So I would not make the choice. I would not make the choice based on performance, but rather on semantics and what you're trying to convey, and how much of this polymorphism mechanism you're trying to use. So, what other points did I? Before we go, let me just say two things, or talk for 2 minutes about, now that we know how to write classes, what kind of classes should you write? And what kind of classes do people write? If you go to that Java documentation, you'll now be able to read and understand most of the information they give you. The Java runtime libraries give you a huge number of classes which you can instantiate and use. And once we get past Friday, most of the rest of the course will be introducing and discussing various aspects of these class libraries. But if you think about what kinds of things you would use classes for, you could kind of classify them, to overload a word, into a number of different uses. One set would be things like our 2D vectors, algebraic type objects that have natural sets of manipulations associated with them. You'll do one in your problem set implementing a class of polynomials. I guess you've done that before in Scheme, so it should be pretty familiar. You just do it again in Java syntax. A lot of the examples you'll see in the book are like, employees and managers, that whole kind of business spin. These, to my mind, are very much data-oriented classes. Why aren't I using a real database to do this, since that's what databases are for? A huge class of, or a huge group of classes that you'll find in the Java utilities and Java runtime systems are container classes. And these are classes whose sole function is to let you store instances of other classes and get them back in different interesting ways. For example, you'd like to have list classes. Rather than arrays, Java gives you a class called vector, which has nothing to do with this. It's basically an array that has the feature that it's auto-sizing. So you can just keep adding stuff, and it'll automatically grow when you add stuff. And that's really nice because you don't have to do it yourself. There are container classes in Java that will do kind of implement dictionary semantics. So you can give this container a key and then an object. Key is maybe a string, the name of the thing, and give this dictionary a bunch of these things, and then say, OK, give me the object associated with this name, and it'll give it back to you. There's classes that implement all these sorts of semantics. There's classes that you can put things in and then ask for them back in sorted order. Java has a whole pile of these sorts of container classes. There's a whole chapter, I think, in Volume 2 about container classes. I/O and network, with Java everything being a class, and system functions being difficult to deal with at a low level, you can encapsulate their functionality in objects. And so there's lots of objects in Java that deal with I/O functionality and networks. And we'll talk about those next week or the week after. Graphics and GUI, graphic user interface, GUI. Probably the single biggest user of object classes and object technology. A lot of really complicated stuff going there, a lot of sharing information between the program and the Windows system and control between back and forth. So there's a huge use of the class technology, all the different aspects, even the most obscure aspects of the class technology is very much used in GUI systems. And indeed, if you look at something like X Windows, which is written in C, straight C, with no object-oriented support, they basically are constructing an object system with inheritance and everything, kind of out of stone knives and bearskins, just to give you the capability, because you need it so much in GUI stuff. A special part of GUI operations or many types of operations are what's called callbacks. Okay, a lot of times you want to write a library or use a library that somebody else has that you want to use it, but occasionally kind of control is supposed to enter it, but instead of returning like a normal procedure call, it's kind of wants to call back into your program lots of different times. Okay, one scenario you can conceive of is, say you're trying to read a file over the network. All right, one way to organize that is to call a routine called or create a structure that reads these files, but now that file has the problem, it knows how to get stuff off the network, but now it has to answer the question of what to do with it once it's got this big pile of data off the network. And one way to address that is you give this network routine a function that it can call when it's got stuff off the network that you tell it where to put it. So you're kind of giving a piece of your program to this library, which then is going to call back to it. And since in Java the only way to pass around functions is as part of a class, you'll see a lot in the next couple weeks of classes whose sole function or sole purpose in life is to encapsulate some function which you're then going to give to somebody else who's then going to call that back for you. Don't worry so much about that stuff. We'll overwhelm you with that next week. The graphic user interface system is a great exerciser of class technology, which is why we're going to do a lot with it, both because it's cool, because you can see stuff move, and because it really exercises all of the different aspects of object-oriented technology, probably more than anything else I can think of. Anyway, I'm trying not to go till noon today, and so have a nice lunch.